Okay, let's take a look at number 29 from chapter 6. And the problem states that you've got these three blocks, A, B, and C. We're given the weight of B and the weight of A. We need to figure out how much weight do we need to put here in order to prevent this whole thing from sliding. So, and the assumption is if this block C weren't here, then the whole thing would slide. That's what part B says over here. So how do we set this up? As usual, we're going to just draw some free body diagrams. I'm going to draw a free body diagram for this whole thing, A and C together, and then I'll draw a free body diagram of B. And then I'll show you like an easier way to go through it. So there's A and C together. Of course, we've got gravity going down. We're going to have a tension going over this way. We're going to have a normal force going up this way, and we're going to have a friction force going back like that. And ostensibly what we're trying to do is equal out the friction force and the tension in order for this to be stable and just about to move. And if friction went down just a little bit, then the whole thing would slide. So we're at this equal point where these two things are going to be equal to each other. So that's this one. Now noting down here, this force of gravity is m times g, but we've got the mass of A plus the mass of C times g on that one. And this is kind of the unknown thing that we're looking for right there. Now, if I draw a free body diagram for B, I've got force of gravity and I've got tension, and that's it. And remember, this force of gravity is going to be the mass of B times G. By the way, this is given as 22 newtons. So just later on, we can plug it in as 22 newtons if we want to. MA times G separately is 44 newtons, so it might be better to just write this as MA times G plus MC times G, and this we know is 44 newtons. And then this is our unknown factor right there. Okay, so ordinarily what we would do is we're kind of looking for this friction force, because buried inside this friction force here, remember friction force is always going to be mu times the normal force, and the normal force is going to be related to the gravity down here. So we're kind of looking for this mu, so we need to find a bunch of things. In order to find the friction force, we're going to need to find the tension and so forth. To find the tension, this tension is the same as this tension, and this is not the same. These are not equal to each other. Actually, they are going to be equal to each other when they're not sliding, but if we're not careful, then we're going to run into a problem with this part. So they are equal to each other when it's not sliding, but once it starts to slide and accelerate, then we're going to run into problems. So I think the easiest way to start for part A is to actually put all the blocks together as we've done before and kind of eliminate the tension between these things. So let's do a free body diagram of all the blocks together. Let's imagine that's all the blocks together. And what we've done in the past is we've said, okay, this gravity force that's pulling down here, if we set up this system, it kind of ends up pulling all the blocks together over to the right. So I'm going to say that that's this one right here, mb times g. And then we've got a force going this way, which is my friction force right there. And then that's sort of it as far as these side-to-side directions go. That's kind of what I wanted to set up for you all, is looking in this side-to-side direction. We've got mb times g pulling this way, and we've got friction pulling that way. And that kind of eliminates the tension between them. We do have to deal with this normal force up here, though, so let's just kind of back up and look at what's going on here. Just to be a little bit informal about it, we could look at this force and we can look at this force, and those two are going to have to equal each other because there's going to be no acceleration in this up and down direction. So I can write that this normal force is going to be all of this down here, ma times g plus mc times g. So that's my normal force, and I can stick that in there so that my friction force is now mu times ma times g plus mc times g. Good. Now coming back down here, we know that if it's not going to slide, this is going to have to equal this. So I'm just going to say friction force is equal to mb times g. Now we have all this up here for friction force, mu mag plus mcg equals mbg. And then we've got numbers for all these things. This is what we're looking for. Oh, no, we have mu. I misstated something back there. We have mu. So that's a number we can put in. And I'll let you all put in the numbers from here. But so just looking back at the problem, mu is a number we know. This whole thing is a number we know. This is what we're missing. We know g, and this is a number that we know. So we can solve for the mass of c. That's actually not so hard to do. Okay, so the second part, b up here, says block C is suddenly lifted off of A. What is the acceleration if the coefficient of friction between the block and the table is 0.15? So just looking at our free body diagrams again, if we want to draw a free body diagram over here, this is just block A. So we've got ma times g. We've got normal force. We've got friction force. And we've got tension. And then block B, once again, is mb times g, and then there's tension. In the same vein as what we did before, so in this situation now, this is not going to necessarily equal this because the whole thing is accelerating, right? But what we can do is we can combine them together like we did before. So there's the combined masses together, and we're going to get mb times g going this way, and then friction force going this way. This one's going to be bigger than this one. So our net force equation is going to be mbg minus the friction force. And that's going to equal the whole thing together, ma plus mb times acceleration. So this is F net equals ma. Okay, so now how do we deal with this friction force? Well, coming back over here, friction force is always going to be mu times my normal force. And once again, I've got a situation where this normal force is going to equal this gravity force down here because it's balanced and it's not accelerating in this direction. So now up here, I can write this is all mu times ma times g. So that's what my friction force is down here. And ultimately, we're looking for the acceleration. So just to write this one step further, I've got mbg minus this whole thing, mu mag equals ma plus mb times acceleration. And these are all things that we know. Now to find ma and mb, we have to do a little bit of work because we have the weight is, or the force of gravity, I should say, is m times g. We're given the force of gravity in the problem. One of them is, 44 newtons, and one of them is 22 newtons. So we're going to have to divide these by g in order to find the mass to stick in down here. But you can figure that out, and you can figure out the acceleration. All right, there you go.